Hello everyone, welcome to the second lecture of week 7. So we have been discussing about applications. We started with question answering in the last lecture and we will continue with question answering even in this lecture. So these will be topics. So we will talk about the open domain QA. How do you train the dense retriever? So we talked about dense retriever in the last lecture, but how do we really train that model is what we will start with. And then we will say, okay, can we also solve question answering in a generative paradigm? So we will briefly discuss the generative question answering part, and then we will talk about other QA data sets, in particular a bit on multilingual question answering, and that is where we will end the question answering topic. So how do we train the dense retriever? So just a quick recap, what is the task that we are doing? You see, we have a question, so a query, and we have a lot of passages, right? So maybe millions of passages, and I want to find similarity of the query with all these passages. So we do something like a by encoder, and we used multiple at least 2 variations is what we saw in the last slide. So we can do like that. We can use in a Colbert setup where we do max similarity of each query token with any of the document tokens, right? So let's talk about this one. So this is also known as DPR, so dense passage retrieval. So it's also popularly known as retrieval, so DPR. Okay, so you are passing the query and the passage separated to encoders, the query encoder and the passage encoder. You are getting the hidden states maybe from CLS, and then you are finding similarity of the hidden states, right? Now, if you have to fine tune these models, you have to get some training signal, some loss, right? So for getting the loss, what is typically done, you need one, given a query, you need one positive example and some negative examples, right? So once you have a positive example, negative example, this is one kind of loss that we can use. That is, okay, this is like taking a softmax over similarity of query and PI plus and other things, right? This is very similar to the loss that we have seen in the case of negative sampling for word to vec. So we had one positive example and other negative examples. This is very similar kind of loss. So you have e to the power similarity of query and passage I. So what this loss will actually do? So when you train using this loss, it will bring the embedding of the query and passage, the positive example close enough, and the query and negative example will go far away, right? So it will tune the embeddings accordingly. So that means we need for each query, we need some positive examples and some negative examples, right? So that is what is a requirement for training data in this particular setup. There is another setup. This is contrastive loss setup, also known as hinge loss. So what you do here, so you need just one positive and one negative example. So suppose for the query, you have one negative example, some positive example, and the loss will be okay. So you take all possible pairs of positive negative examples. Even if you have more positive negative pairs, doesn't matter for the same query. You can add this loss for every possible pair. Now, what is this loss? So you compute a score for query and negative passage, query and positive passage, right? And you subtract from negative to positive and take a max of 0 and that, right? So what is the rationale? So if SQD negative is higher than SQD positive, that means you are not doing good, right? Your model is not doing good. It is giving a higher score to negative than positive. So in that case, this quantity will be max of, suppose this is x, so difference is x, let's say. So max of 0 and x, which is x is positive in this case. So x is positive, right? So I will have a positive loss and I will tune my parameters using that loss. But on the other hand, if already SQD negative is less than SQD positive, so you are doing good. You are already giving a higher score to positive document then the negative document, and then this quantity will be max of 0 y, and where y is negative, right. So, because this is higher than this, so it is a negative quantity. So, y is negative. So, max of 0 and negative quantity will be 0. So, there is no loss added for that. So, that is the contrastive loss that can be used, and you can also use that to train your dense retrievers. Now, given these loss functions, there may be other variations also. The question then comes out, how do you bring the how do you make the corresponding data, right. So, what may happen, so in the data set, many data set you only have the query and the answer string, right. So, you have a question and an answer string, right, but you do not know, you are not given any annotation to which passages this answer lies in, right. So, you are not even given the positive examples, except maybe when you are doing reading comprehension kind of question, you may be given, okay, this is the passage from which this example is taken. So, then that passage is positive example, every other passage is negative example, right. But many data sets just will have question and answer string. So, how do you create this synthetic data training data set where you have the query and some positive passage, negative passage? So, the trick here is, so what you can do, like sometimes the positive examples may be provided already, like in reading comprehension data sets, or may not be. So, if they are provided, you anyway take them, right. This is a plus for you. But if they are not provided, the trick is that, okay, so we know BM25 is a good approximation, right, but it cannot be taken guaranteed for the correct relevance. So, what I can do, given the query, I use BM25, which will be very fast, over the entire set, right, entire set of passages. And let us say I get some passage with a high BM25 score. Now, I can't take all of them as the positive example, because that was assuming that BM25 is the ground truth, but then your method can only go as far as BM25, right. So, I do not want to do that. So, I want to now make use of the fact that I have the answer string, right. So, what I can do in all these passages, say passage P1, P2, I will check, right. I can directly check if the answer string is present, right. So, that is a simple hack. So, I check if the answer string is present. If it is present, that passage is known as the positive example. So, I will take that as a positive example, because that is a high, I mean that is a high chance, because BM25 is saying it has a high score and it contains the answer string as it is. So, let us take that as a positive example. Okay. Now, what are the negative examples? So, I can say I will randomly choose some passage from the entire data set, right. So, apart from this to make my negative example. So, that is something you can always do, and that are okay. But you can always also do some other things, like in these passages that are having high BM25 score, there are passages that do not contain the answer string, right. So, that are more likely to be not relevant. So, you can take those passages that are written by BM25 that do not contain answer string, but they have a high BM25 score, right. So, that can be some hard negative examples, because they are similar as for BM25, but they do not contain answer string, right. And similarly, you can take positive passage of other questions. So, that is another way of choosing, because they were good passages from which questions were created. So, you can take them as negative examples. So, many times what is when we are creating such data sets, a lot of effort is done to ensure that your negative examples are good. If you take some random negative example, the model may not learn good, and may not have a good distinction between, say, the passages that are having high similarity, but still do not answer your question, right, versus those that answer your question. But by creating hard negatives, you are able to make the distinction. So, hard negatives is a very important concept that is used in such kind of contrastive learning setup. And this particular thing is also known as relevance guided supervision, because you did not have a ground truth passage available to you, but you use some relevance to find out what are relevant. I mean BM25 to make it some approximation, right, and on top of that you use the answer string. So, that is how you can create data set, and you can train using the models, fine tune the BERT encoder, and then use that, right, as the first step. And second step we talked about, you can use the reader, right, you can use the reader. So, we talked about one particular method for reader. So, you use various particular, so once you have passages retrieved in this phase, you can get the scores as per the reader and choose the one that answers your question. So this is how this method works. Now there are also retrieval free approaches where you don't have to retrieve. Yeah. So the idea is that okay, I am trying to find answer from Wikipedia, but my models have been trained on Wikipedia anyway. So won't they store the knowledge already, right? So can we not query the language models to obtain the answer directly? So that has been one line of thought, and so they should be able to memorize a fair amount of information. So if I query them already with these questions, they may be able to answer directly, right? So that's where this GPT-2 was used for zero-shot question answering. So without any training. So on a particular data set, I'll talk about this. So natural question data set, and what they found, it had already 63% accuracy on 1% of the question was very confident in, right? So this was a first step, that you can do zero shot, but we can even fine tune these models to be able to answer these kind of questions. So efforts were done. For example, I can use an encoder decoder setup T5, right? And this is a question answering task, so I can frame my input like that. So this is my data set, say square data set. At what speed did the turbine operate, and then I can give the entire paragraph, right, as the input. So I give the question and the paragraph as the input, and I generate the answer, and I find in the model so that given the question and the paragraph, it generates the span, right? So it can generate the span rather than selecting. So that was what is done for squared. Another kind of data set, like there were narrative QA, where similar, you have a question and a narrative, you answer the question. There are some multiple choice question, you can give the question and the choices, all choices in the input, and get the output, one of the answer, and so on. And there are some Boolean questions where you have to just answer yes and no. So everything can be done in a generative manner, where you feed all the information in the input and you generate the output, right? So they did it for T5, but one can also do it for other decoder based models, where you can feed all of this like a prompt or like an input prefix, and you can generate the output. You can fine tune the model, right? So you feed in the input passage in question, decoder to generate the to output answer, right? So this particular work was unified QA. So we take multiple data sets and they formatted in this particular format, and they use T5 model to answer the question. So you can also use generative models to answer the questions by putting all the information in the input and then getting the model to generate token by token, right? Now when we're talking about generator, so can we not combine the ideas of retrieval and generation together, right? And that's what we will talk about in more details later, but at this point we can just mention it. So remember this retriever reader framework. So you have a large corpus, and I have a retriever that can retrieve some passages. So one idea can be, so my language models can work with a prompt. So, and we saw that we can give the question and all relevant information there. So all relevant information for open domain questions. So this is for open domain question where you do not have the passage already available. Given the question, you can retrieve the relevant information and pass it through the LLM, right? So you retrieve it from the retriever. So like here, we were already passing this information to the model, but you can retrieve it using the retriever and the relevant documents and the query. You can pass it to the generator and let it generate the output, right? So that's a possible framework, and that has become very, very popular. So this is what is known as retrieval augmented generation, the RAG paradigm. So what we do, we take a large pre-trained model, so here, and we give it the set of retrieved passages and other text as prompt. So in the prompt we have the question, relevant passages, and we let it generate the answer, right? So it's generating the answer, not retrieving it. So in the retriever reader framework, we were trying to select a span, but now we have combined the generator and the retriever here, right? So this is the retrieval augmented generation paradigm, and this has become like very, very popular recently for doing question answering. Okay, so now let me talk about some other data sets. So one particular data set was natural questions. So because the previous square data set, what was happening, you select a passage and people were creating queries on that. They were not natural questions that people were asking on Google. So what they did here, so they took some real anonymized queries that were issued to Google search on 8 words or more, right. So, it took all the queries that people have actually issued on Google, and an annotator what was done. So, the annotator was given the Wikipedia page from the top 5 search results and the question, and the annotator annotates like a long answer for the question and also a short answer, right. And if the document, if the paragraph does not contain the answer, it will also mark it that it's not present. Right? So that's the idea. So you have a question, you have the particular page, and you have a long answer and short answer, and that is present to you, and you can evaluate your model on generating long answers, short answers, and so on. Another very popular data set was hotspot QA. So, where they said, okay, can we make the model do some more reasoning, because many times in the previous kind of data sets the reasoning part was not there, you just have to retrieve it from somewhere in the paragraph. But what kind of reasoning do you mean? So, it means it reads 2 or 3 sentences and tries to reason from that. So, what they ensured is that whenever you have to create a question, it should make use of information from multiple paragraphs. So, like here what they will do, they will select 2 paragraphs, paragraph A and B, and you have to frame a question that uses information from both of these. So, only if a model reads both the paragraphs can the model answer the question. Like here, the 2015 Diamond Head Classic was a college basketball tournament, and Buddy Hield was named the tournament's MVP. And Shavano Renier, Buddy Hield is a Bahamian professional basketball player for the Sacramento Kings of the NBA. These are the 2 paragraphs, and your question is which team does the player named 2015 Diamond Head Classics MVP play for, right. So, first of all you have to find out who is the player who was named 2015 Diamond Heads Classics MVP, that you get from the first paragraph. This you retrieve here, and then what is the team that person plays for, and this you find here, right. So, this is and this is the team, in the green you have the team. So, that should be your answer, right. So, you are getting information from 2 different paragraphs, combining it and answering your question. Similarly here, so they are like different reasoning types. So, bridge entity. So, like here, did Lost Alone and Guster have the same number of members? So, you will have information about these in different paragraphs, right. So, this is the members and this is the Guster. So, and the answer is yes, right. So, you read 2 paragraphs, you find the number of members for each of these and say. Similarly here, which former member of the Pittsburgh Pirates was named the Cobra? So, yeah, I mean again you have to do reasoning, and same here. What city in the Marine Air Control Group, what city is the Marine Air Control Group 28 located in, right. So, you have to find out what is Marine Air Control Group 28, right, and then located in somewhere else. So, yep. So, this is like again a bridge entity that you have to use to get the answer. So, this again became popular because now the kind of methods you have to use will be different, right, than what you were using earlier. Now, let us talk about multilingual question answering. So, till now we have only focused on question answering when English is the domain for English is the language for both question, answers, and even the text corpus from which you are retrieving the information. Now, how do you support questions in another language, and can we search against a corpus in another language, right? So, one simple version can be when you just do everything for another language, right. So, you may have questions, answers, text corpus in one language like Chinese, and you can ask question in Chinese, retrieve from Chinese corpus and answer. So, this will be like very similar kind of setup. You have a model that understands that language, and you can do the same kind of models you can use for answering these questions. But a more interesting setting would be where you have a query. Let's say you want to ask in your native language, say Tamil, and you would prefer an answer also in Tamil, right. But the documents from where the answer is being asked may be in any language, say in English, right. You are asking something from an English document, but you are asking in Tamil and you want the answer again in Tamil, right. So, that is a very relevant setup, and this is also known as cross-lingual question answering, right. So, this has also become very popular. Now, how do you typically achieve that? So, one approach can be that okay, I have trained my models to work on English question answering, right? Given English corpus, English question, I can give English answer. But at the same time, I have some multilingual models. So we talked about XLMR and so on. So let's say I take a multilingual encoder, XLMR. Now this multilingual encoder also understands English and these other languages, right? So what I can do, I can take this and fine tune it on QA dataset, English QA dataset, right? So now it can do question answering, and it has been trained for English. Because we had a lot of resources for English, may not be so much questions for other languages. Now it would have learned about question answering now, and because ideally it's a multilingual encoder, so now I can feed it the another language question, and it knows question answering, so it can possibly do that also, right? So this is the zero shot transfer. So I only train it on English question answering data set and see how good that can do over other languages. And we saw they do to some degree that they do zero shot transfer, right? You just train it on English and they have some zero shot capability. So something like Mbed versus XLMR, so they do some like 53% accuracy. But what was found that apart from doing the zero shot transfer, if you do at least some examples, right, of the language that you want, like 2 examples, 4 examples, 6 examples, there is an improvement in score, right? So at least some improvement in score. So it's better if you give some more examples in the language. So it helps. Right? It was helping a lot with Mbed and a little bit with XLMR. So this is the zero shot transfer case, right? But there can be other approaches. For example, you can do adapt using translation. So you can also do translation of the data. Now, what will you translate? So right now at test time your question is coming in Tamil, and you want the answer in Tamil, right? So one thing you can do is to simply translate the test part. That is called translate test. So what you will do, your question is coming in Tamil or any native language. You translate the question to English, right? And now once you translate the question to English, now the question is in English, your data is in English, you query it, right? So you apply any off the shelf English QA system against the English text corpus, get the answer, and then answer you translate it back to Tamil or the native language, right? Translate the answer back into the language of your choice. That is translate test. You didn't do much. I mean, you just translated, you just changed the interface, right? So you took the language in Tamil, you translated it into English, did everything in English, and then finally the answer you translated back to the language, right? Now, this is a good approach, but the problem is that you are assuming the translation from that in native language to English and English back to native language is of very good quality, right? But if there are errors there, so these errors will propagate, right? If you cannot translate your question correctly, it will not retrieve the correct answer, right? And then other problem, of course, is that the answer has to lie in English corpus. What if you wanted to search in your native language, right? So that native language corpus, that you cannot do. So another variation for the same thing that does not resolve all these problems though, it's called translate train. That is fine. You have the original data set, right, on which you were training the English QA models. Now translate all the data to your native language, right? So translate the full training data set, including question, answers, and the text corpus, to the target language. And now once you have this large data set already with this translation, you train your model in the target language, and at test time again you get the target language question. You don't translate it to English. You just use this model to retrieve from these corpus everything in the native language and get the answer, right? So here you do everything at the train time. At test time you don't have to do any translation, right? So this is translate train approach. Again, it suffers because first of all you need a lot of translation because data set can be huge, and you have to translate everything to your native language. That can be a lot of task, and yeah, again the empty errors may be there, so it can be noisy because of that. Now a third approach that is like assuming that the multilingual methods works is that okay, so why do we need to do all that? So we can just take data from all possible languages, right? So what you can have, so you can have a multilingual dense passage retrieval, right? So you can include Wikipedia in different languages, assuming it also covers the language in which you are asking question, and let the question come through this, and it will retrieve it from any language, right? It will, because it can find similarity across languages, it will retrieve documents from any languages, right? Multiple languages. So there is an answer in English and also another language. So you get all these passages in multiple languages, and then you use a generator to generate the answer, and that will generate the final answer, right? And this generator can be something like MT5, that can, the encoder can understand multiple languages. It can also generate in multiple languages, right? So you can use here like MBERT or XLMR for your retriever and MT5 for your generator. So that's one approach. You do everything in multilingual space. You don't worry about translation. You just put trust in your multilingual encoder and the decoder models. So this is another possible approach. But yeah, I mean, it's a very interesting research area. A lot of approaches keep on coming. So there are also a lot of data sets that are developed. So one is like X squared data set. So it's simply the squared data set that has been professionally translated by manual professional annotators into 10 languages, and now you have that all everything available in 10 languages, so you can use that. Then you have MLQA dataset, which has 5K samples in each of the 6 languages and also in English. Then MKQA dataset, where the natural questions were translated into 26 languages, and it assumes answer can be found from English Wikipedia. And then the Tidy QA, one of the recent ones that is very popular again, that is 200,000 question answer pairs that are collected naturally in 11 languages. Right? It's not translation, and you have each language's native Wikipedia as the text corpus. So these are some popular data sets. Specifically, Tidy QA has recently been very popular. Okay. So now I'll just end this question answering module with just one more idea, that see, you can use these ideas for other modalities also, where text is predominant. Like one place where text is predominant is like tables. So like you have this question, right? What was the reported mainline RPM for American Airlines in 2017? And it would be present in some report, right? Some report where you have the mainline, and then you have different rows, and the columns are giving across years what is the RPM value, and you want to retrieve this number. So you see, if you can make use of the row name, so what is the row heading and the column heading, you may be able to answer this question, right? So this is a very simple extension to the text-based task, but you have to do a lot in understanding the tables, right? How do you make use of this information that is provided in the table? And there have been a lot of data sets. So this is a 2022 survey paper that lists some data set, but after that also a lot of data sets have come up. Like one particular is financial domain question answering, where you have some very interesting questions from a table that is in the financial domain. And you have data set which has only table, and some data sets also have some description of the table. So you have information from the table and also description. Description can be the caption given to the table or when you describe the table, right? So you can have lot of different information, but text is one of the prevalent modes. So you can use your existing methods, but you have to do some tricks in how do you make use of this tabular data, right, to feed to the models. Like I'll just give you one example of this TAPEX model that was proposed in 21. So they said, okay, I can even pre-train my models, right? I can pre-train my current models to, so this pre-training can be done for say GPT-2 kind of models, decoder models, or the encoder models. So what they said, okay, pre-training, I need the model to learn the tables, right? So what they did, so first of all, how do you present the table, right? How do you tokenize the table? So they use the idea of flattening. So they said, okay, this is my table. So what I will do, I'll say, okay, head, I'll put all the columns, year, city, country, nations, right? This is the heading of the table. Then the row. So row 1, so you put everything, 1896, some separator, Athens, and so on. Then you put row 2 and all. So you put all the information in a flattened form. And then, because you are pre-training, you need some data to fine-tune your model. So what they did, they said, okay, given a table, I can create some synthetic SQL queries, right? So you synthesize some executable SQL queries, and you also get the answer for those queries. So you ask the question, right? You ask the question to the model, and you know the answer by the SQL executor. You know the answer, and let the model predict that answer, right? So, and that's how you pre-train the model. So, by synthetically generating a lot of SQL queries. In a test time, what you will do, you will have a natural question, but now your model has learned this particular format, so this flattening. So you can, given this question, you can generate the answer, right? You can retrieve the answer depending on whether you're using encoder setup or decoder setup. Now, people have also made use of the fact that you can also try to retrieve rows from here, the columns from here. You can have a retriever setup where you retrieve information from this first, and using the retrieved information, you try to generate the answer, or again retrieve the answer, right? So that means you can extend the ideas we talked about to tabular domain. What you have to learn is that how do you convert this table to a text format, and how do you retrieve from that, and there have been works around that. And yeah, I mean, this is a very vast field, question answering. We have covered a few topics, and I hope you will be able to use that to even read more about multiple different domains, right? So, and chapter 14 of the book talks about it, but the more recent parts you will find in the papers that we have referred. So, we will talk about some more applications in this week. Thank you.